Hi everyone, and welcome to our introduction into the unit circle. This is found on page 213 in your Springboard books, and we're going to look at labeling the points on the unit circle and using the unit circle to find some trig values. So if you see here on our unit circle, we have some degree measures marked, and if we kind of continue this trend using reference triangles as our guide, imagine we drew in all of these reference triangles that are this same distance from the x-axis. These are all basically members of the 30-degree family, if you will. Well, we know that we are at 90 degrees here on the positive y-axis, 180 on the negative x, and we are down at 270 for the negative y. Well, with that information, if we're 30 degrees back from 180, we're actually at 150. 30 degrees beyond is at 210. And then if we were back here at 360 degrees, 30 degrees before that, we would have been at 330. So each of these are basically in reference to this original quadrants triangle. So all the 45-degree reference angles can also be drawn in, and the process is the same. Think about how far are you from your x-axis. So we're at 45 degrees before 180, so that would put us at 135 degrees, beyond 180, 225, and then before 360, 315. And then last but not least, it would be done the same way with our 60-degree angles. Okay. So 60 before is 120, 60 beyond is 240, and then 60 before 360 is 300. Okay, so there's our degrees on the unit circle. Now from here, what we can do to figure out the radian measures is convert them using the pi over 180, and 30 degrees is pi over 6, pi over 4 we would have, and then finally pi over 3 would be our conversion from 60 to radians. Now again, kind of like the reference triangles before, I always like to think about where are my coordinates at, because 90 is pi over 2. Right? We know that back here would be 2 pi. We know we're at pi over here, and we are at 3 pi over 2 down here at the negative axis. Well, using that idea of reference triangles, all of the members of the 30-degree reference triangle family are members of the something pi over 6 family when it comes to our radian measures. So for instance, this is going to have a denominator of 6 still. This is going to have a denominator of 4 still. This will have a denominator of 3 still. Again, going back to what reference triangle it was with the degrees. Now, I always like to think if you're at a full pi, right, you're at 5 pi over 5, 6 pi over 6. It would reduce to be 1 pi each time. 12 pi over 12 reduces to be 1 pi. All of the values in quadrant 2 are not quite to 1 full pi. If you were to convert all of these degree measures, 120 degrees, 135 degrees, and 150 degrees, it would come out to these 3 values, which again, to me, I always like to remember them as 1 less than a full pi. Kind of the same idea here then in quadrant 3, they're always 1 beyond a full pi. So these are still going to have those same denominators, but instead of being 6 pi over 6, this is now 7 pi over 6, 5 pi over 4, and 4 pi over 3. So 1 beyond the denominator. Last but not least, over here in quadrant 4, you're not full to a full 2 pi. So like 12 pi over 6 would be 2 pi. So instead, we're at 11 pi over 6, 1 before we would be at full 2 pi. And then this is still denominator 4, this is still denominator 3. And then if we bring it backwards, it is 7 pi over 4 and 5 pi over 3. And again, you're officially able to, convert these each time. And now you'll have a filled out unit circle anyway to reference, but that's how I would remember these if we were in class and having to memorize them. Okay. Now, the measurements from our unit circle then are going to be found by looking at this figure here and using special right triangles. So we know in 30, 60, 90 right triangles, we have the short leg is the x, You double it to find the hypotenuse, and the side across from the 60 is whatever your short leg was times the square root of 3. Well, if we had to kind of reimagine this so that we were given the hypotenuse, we know that we have to divide that value by 2 to find the value of the short leg, and then the long leg is that value times the square root of 3. Okay, so with that knowledge, that's how we find all of these other values on the unit circle for what coordinates they are at. So a reminder, when we are talking about the unit circle, that means that our radius each time is 1, no matter what, okay? So here, our radius is 1. So if we divide that by 2, the side across from the 30 is 1/2, and the side across from the 60 is 1/2 times the square root of 3, aka the square root of 3 over 2. So if we kind of put that onto this red triangle, that's what we would see. This would be 1, this would be the square root of 3 over 2, and 1/2, right? Because this was a 30-degree angle. So that means this coordinate here is at x comma y, square root of 3 over 2, comma 1/2. Well, just like we were talking about before, all of these reference triangles, if we flipped this over, would be the same. Or if we flipped it down, we would see the same thing, right? So all of these reference triangles officially are going to have this same measure, right? They're all the same size, square root of 3 over 2, 1/2, square root of 3 over 2, 1/2, and square root of 3 over 2, 1/2. The only difference here is that what quadrant they're in is going to dictate what kind of signs it has. If you're in quadrant 2, your x value is negative because you move to the left. Quadrant 3, they're both negative because you move to the left and down. Quadrant 4, just your y value is negative, okay? So this is going to be the same as well for the 60-degree angles. The only difference is it's going to be flip-flopped, because in the 60-degree angles, what's happening here is we have the 60-degree angle here, and we need to flip-flop these so that now it's going to actually be, this is the square root of 3 over 2, and this is the 1/2 value. So we would have basically our x and y coordinates flip-flopped here. But again, as you move around the circle, these are all the same values at the 60-degree or pi over 3 markers. The only difference will be each time is where does your negative value go in all of these. And in this case, everything is 1/2, square root of 3 over 2, and then 1/2, negative square root of 3 over 2. All right, last but not least, with the 45-degree angles, those we are going to reference back actually the 45, 45, 90 triangles. So in the case there, you would have square root of 2 over 2 is how we would find these, using the 45-degree shortcut, where you'd have to divide by the square root of 2 and rationalize. So same kind of idea, you would just keep that square root of 2 over 2 idea, but your x value is negative in quadrant 2, x and y values are negative in quadrant 3, and finally just the y value in quadrant 4. The other pieces, again, are based on the fact that this radius is going to be 1 unit long. So we would be at 1, 0 when we're at 0 or 100 or 360 or 2 pi. We're at 0, 1 here. We went left 1s, negative 1, down 1 to negative 1 for the y would be then your axis values of this. Okay. So again, nicely filled out. This will be attached to look at. But I would definitely recommend you having this handy for you. One advantage of e-learning is you get to actually have all of this in front of you at all times, which will hopefully make things a lot easier for you. Okay. Now moving on to a couple other things here that we have going. Okay. Notice because of the unit circle's values, with the radius being 1, each time what happens with our sine and our cosine is because the denominator is 1, because of the radius being 1, your cosine value is always going to be associated with your x, your sine value is always going to be associated with your y because of those facts. And this goes back to what we've been talking about with sine and cosine in previous lessons in these. So very important to kind of have that piece, as well as the fact that in the unit circle, cosine is with x, sine is with y. Now, in number 2, then, again, that kind of covers what we just said, that your sine value, because of the radius being 1, we can just assign in the unit circle, sine is associated with your y value. And same thing for cosine. So, moving on then to part 3, whoops, skipped over. Part 3 says, and 4 then down here says that based on this information, if we're looking at our unit circle, cosine of 45 degrees, well, definitely make sure you have your unit circle handy to reference here. But if we're looking at cosine of 45 degrees, that's your x value, which would be square root of 2 over 2. Sine of 2 pi over 3, if we look at 2 pi over 3 on our unit circle, the sine is the y value, square root of 3 over 2. Sine of 180, again, deals with the y value is sine. We have 0. And then cosine of 7 pi over 6 is the x value at 7 pi over 6. So that's negative square root of 3 over 2. So that is how you would answer these particular questions that we just looked at. Again, cosine is the x value, so square root of 2 over 2. Sine is the y value at 2 pi over 3, which we said was, for a second here, the y value at 2 pi over 3 is square root of 3 over 2. Sine of 180 is the y value at 180, which is 0. And cosine of 7 pi over 6 is going to be your x value, so negative square root of 3 over 2. Moving on then to the idea of tangent is asking about the slope of these angles. Now, tangent we are going to describe as your y value over your x value, or the sine over the cosine. And the reason being, if we think about our triangles, we had moved x over y, so the slope of this is the rise over the run, aka the y over the x. So that's where tangent comes from, is basically the slope, the rise over the run, which in this case always becomes y over x. Now, to look at some of these specific values of the slopes, you need to think about, okay, what is the y value over the x value? Well, at pi over 6, we're at the point square root of 3 over 2, comma 1/2. So the exact slope is your y value divided by your x value. Well, your y value divided by your x value, if we simplify this, the 2's in the denominator cancel out. We have 1 over the square root of 3. But we don't like to write this as the radical in the denominator, so we have to rationalize, and we end up with an exact value of square root of 3 over 3 because of that, which is approximately 0.577. Now, if you took your calculators and notice pi over 6 is a radian measure, and we took this in radians, tangent of pi over 6 is approximately the 0.577, which is also that approximation of the square root of 3 over 3. So we can kind of double check that that makes sense, that that was the approximation for that. Okay. Now, any of our 45-degree angle family members are nice, because in this case, we are at square root of 2 over 2, negative square root of 2 over 2 and square root of 2 over 2. So y divided by x, you're dividing something by itself, right? Just negated. So that would just end up reducing to be -1. And again, we can test this out. This time we are dealing with degrees. I have to flip-flop back and forth a lot, unfortunately. Tangent of 135 degrees is -1, okay, which again is what we got when we, found the approximate versus the real. Okay, last but not least, 4 pi over 2 is going to be located in quadrant 3, and 4 pi over 2 is at -1/2 negative square root of 3 over 2, which if we reduce y divided by x, these cancel, the negative cancel, and you're just left with square root of 3 over 1, which is just the square root of 3. which again can be found by checking the approximation. The square root of 3 is about 1.732, and if you put your calculator back in radians, you would see that the tangent of 4 pi over 3 is also 1.732. So you can always check this out by typing it into your calculator. Now again, be very cautious of your mode to make sure that you're doing this correctly. So 4 pi over 3 is again the same value as the square root of 3. So we could check that we did that correctly. All right, so again, tangent is in terms of your y value over your x value each time and being able to simplify. So final few examples here. Tangent of 45 we talked about is going to involve using the square root of 2 over 2 and the square root of 2 over 2, which is just 1. At 2 pi over 3, we are at negative 1/2 square root of 3 over 2. So y value over x value, these cancel, we're left with negative square root of 3. Tangent of 180, you're at negative 1 comma 0. So 0 divided by negative 1, y over x is 0. And last but not least, at 7 pi over 6, you're located on the unit circle at negative square root of 3 over 2, negative 1/2. You're in quadrant 3. And then y divided by x, again, negative 1/2 divided by negative square root of 3 over 2. These cancel, so the denominators. And we know that we need to rationalize this to just be square root of 3 over 3. So very similar to what we saw with the unit circle values for x and y, the tangent values kind of come out to be the same, different forms of answers. 1, negative 3, 0, square root of 3 over 3. You'll see these patterns occur. Now, tangent of 0 is at 1 comma 0, right? So the tangent would be 0 divided by 1, which is just 0. At 90, though, you're at 0 comma 1. So 1 divided by 0 is actually an undefined value. You can't define anything by 0. So one of them is 0, one of them is undefined, okay? Tangent, though, of 0 and 180 are going to be the same because we just found that tangent of 0 is 0. We found that tangent of 180 is 0 as well from above here. So we know that they are the same. So 90 and 270 are actually going to both be undefined, the tangent of 90 and the tangent of 270, because of dividing by 0. They're both undefined. But tangent of 0 and tangent of 180 are the same. They're both going to be 0. Okay. We will work more then with this next piece in the next part of this. Thanks for watching.